Hello. In this video, I will continue to solve the exchange economy from the previous video. Step 4 is to equate the marginal rate of substitution of player A with the marginal rate of transformation, which is just the price ratio. If you've done some previous constrained utility optimization, you will recognize this as the standard first-order condition for optimal consumption. This simply states that the value of good 1 in terms of good 2 must equal the price of good 1 in terms of good 2. That's what equation 3 says. Now, one thing we can do is to impose that the price of good 1 is equal to 1. And the reason for this is that it doesn't matter what unit of measurement we have for the prices. The only thing that matters is the price of good 1 relative to the price of good 2. So, for example, we can measure the prices of these goods in euros or in the US dollar or in the Swedish crown or the Russian ruble. It doesn't matter. The solution should be the same. So we can assume that the unit of measurement is such that the price of good 1 is equal to 1. The reason for this is just to simplify the math, because if we make this assumption, one of the parameters of the model disappear, and we can then solve for P2 as I've done in equation 4. Step 5 is to substitute P2 in equation 4 into the monetary constraint of player A, which gives us equation 5. You then solve this for x2a, and this together with the contract curve gives us a system of two variables, x2a and x1a. And we can then solve this system, which gives us a unique value for x1a, which is 108 divided by 19, which means that we have found the optimal consumption of good 1 for player A. Then, having found x1a, it is easy to find the other variables in the model. You just use the equations, which we have already used previously, to find x2a, x1b, and x2b. And from equation 4, we can then find the price of P2. And since P1 is equal to 1 by assumption, we have also found the price ratio. So we're actually done in deriving the solution. However, there's one more thing we can do. Having found the price ratio, we can put those numbers into the monetary constraint for player A and get equation 8, which is just the budget line for player A. That is, it is the constraint for how much player A can purchase with the initial money, the initial monetary worth of his initial allocation. And we can then argue that since they will always trade along the price ratio with these prices that we have derived, they will trade along this line when they trade towards the contract curve, which then means that the solution, the optimal point which we have derived, must be graphically in the Edgeworth box at the intersection between this budget line and the contract curve. Here's what it will look like in the Edgeworth box. I have plotted the contract curve, the indifference curves that go both through the initial allocation C1 and the optimal allocation C star. I have plotted the core, which is again the blue line, and I have also plotted the budget line of player A. So they start at the point C1, they then trade along the budget line, down and to the right. Player 1 is buying good 1 and selling good 2, and player B is doing the opposite. As they do so, they move towards the core, and eventually they reach the point C star, where they stop trading, because at this point the marginal rates of substitution are equal, so they can no longer trade in such a way that both of them benefit. Before I end this video, I want to say something about how we found the point C star. So I had already concluded that the solution must be in the core. It must be on the blue line in the Edgeworth box. But now we have identified one of those points on the blue line, and we say that this is the unique solution. How can we argue this? Well, the idea is that when they trade towards the core, they must do so at a price ratio such that when they reach the core, the marginal rates of substitution for both players are equal to the price ratio at which they trade. In other words, the slope of the budget line when it crosses the core is equal to the slope of the indifference curves at that point. This is how we were able to identify one specific point in the core and say that this is the solution. Now, in some models, you cannot do this. It can be, for example, because there is no point at which the players have the same marginal rate of substitution. Or it can be that the marginal rate of substitution is not defined at all. Both of these things are possible. And in those cases, you cannot use the argument that I just used here. But you can still always conclude that the solution is on the core. Even if we can't identify one specific point in the core and say that this is the unique solution, we can always say that the solution is in the core.